Hi students, I'm your Nagini ma'am, chemistry mentor. In today's session, I'm giving 5 excellent tricks to answer the MCQs of Lechatelier principle. Very important topic students, 11th chemistry chemical equilibrium lesson. Okay, in pharmaceutical industry students, to get the good yield of the product, they will follow some favorable conditions students. Those conditions given by the Lechatelier principle. Understanding, they will follow the Lechatelier principle to get the good amount of the product. Okay, so here what is the Lechatelier principle? If any change is done at the equilibrium, okay, at the equilibrium state, then the equilibrium will shift in the direction where it can minimize the effect. So what type of changes students? It is applicable, Lechatelier principle is applicable only at the only for the reversible reactions students. Are you following? It is applicable only for the reversible reactions. So when we are changing the conditions during the chemical reaction at the equilibrium state, concentration, pressure, temperature, catalyst, inert gases, any condition, okay, now if you are changing, what will happen students? The equilibrium itself, it is minimizing the effect. Understanding, it shift in the direction where it can minimize the effect. For example, concentration. So whenever concentration of the reactant increases, okay now, reactant concentration increases, then equilibrium tries to shift in the direction to decrease the concentration of the reactant. Are you following? Equilibrium tries to decrease, clear, tries to decrease in the concentration of the reactant A. Clear students? So here whenever increase in the concentration of the reactant A, then equilibrium tries to decrease in the concentration of the reactant A. Are you clear? So if suppose product concentration, whenever product concentration increases, then what happens students? Equilibrium tries to decrease in the concentration of the product B. Are you clear? Decrease in the product of the concentration of the B. So whatever the changes we are doing during the chemical reaction at the equilibrium state, what is happening students? Equilibrium tries to increase or decrease in the concentrations of the reactants or products. Are you clear? So that is nothing but Lechatelier principle. That means equilibrium itself, it is minimizing the effect and it is shifting in the direction to minimize that effect. If any change is done at the equilibrium, then the equilibrium will shift in the direction where it can minimize the effect. Are you clear? So here whenever concentration of the reactant increases, then equilibrium tries to decrease the concentration of the reactant. Are you following? If suppose we are increasing the concentration of the product, then equilibrium tries to decrease the concentration of the product. That means whatever the conditions we are changing, then the equilibrium, according to that, the equilibrium minimizing that effect. Are you clear? Itself it is minimizing the effect and it gives the good yield of the product. Clear? Right. Now first we will discuss the concentration effect, Nana. So first one, concentration effect. What is the concentration effect? See here, concentration effect. So in case of concentration students, here concentration of the reactant. For example, the concentration of the reactant increases. If you are increasing the concentration of the reactant A, clear? If you are increasing the concentration of the reactant A, then the equilibrium has to shift in the direction to decrease the concentration of the reactant A. Understanding? That means equilibrium itself, it is minimizing the effect. Okay now. So here tries to equilibrium it is tries to decrease the concentration of the reactant A. Understanding? So that's the equilibrium has to shift in the direction, has to shift in the direction to decrease the concentration of the reactant A. Clear? To decrease the concentration of the reactant A. Understanding students? See here. So whenever concentration of the reactant A increase, then the equilibrium has to shift in the direction to decrease the concentration of the reactant A. So we know that in every chemical reaction, the concentration of the reactants gradually decreases in the forward reaction and the product concentration gradually increases. Correct or not? For example, A to B we are taking, A to B. So here, concentration of the reactant A in the forward reaction, what happens students? Increases. Concentration of the reactant decreases and the product concentration gradually increases. In any chemical reaction you take like this, it is happening. Okay. Now see here, whenever concentration of the reactant A increase, then equilibrium has to shift in the direction of the concentration of the reactant A, decrease in the concentration of the reactant A. So in which direction the reactant concentration A decreases, students? In the forward reaction. It is the forward reaction. So in the forward reaction, the concentration of the reactant gradually decreases. So that's why here it favors the which direction, students? Favorable. It favors the forward reaction. That means equilibrium has to shift in the direction to decrease the concentration of the reactant A. Decrease the concentration of the reactant A. So here in the forward reaction, the concentration of the reactant A decreases. So that's why here which reaction is favorable, students? Which reaction is favorable? Forward reaction is favorable. That means equilibrium shift in the forward direction. Forward reaction is favorable. Clear? So in the forward reaction, concentration of the reactant decreases. So that's why equilibrium shift in the direction, forward direction. Clear? So this is the first case. Now I am taking the concentration of the product B. See here, product B I am taking. See here. Suppose the product B concentration increases. So then equilibrium has to shift in the direction to decrease the concentration of the product B. Equilibrium has to shift in the direction to decrease the concentration of the product B. Are you clear? To decrease the concentration of the product B. So in the reaction, in this reaction, A gives rise to B. In which direction product B concentration decreases, students? Here product B concentration decreases. That side equilibrium is shifting. So that means here if you are taking A gives rise to B, see here in the forward reaction, the concentration of the reactant A decreases, product B concentration increases. In the backward reaction, what happened? The product B, the product B concentration decreases, reactant concentration increases. Correct or not? So here equilibrium has to shift in the direction to decrease the concentration of the product B. So a decrease in the product concentration, decrease in the product B concentration means which reaction is favorable? Backward reaction is favorable. Are you clear? So that's why here backward reaction is favorable. That means equilibrium shift in the direction backward direction. Are you clear? Backward reaction is favorable. Clear? To get the good amount of the product. Now first trick number 1. So what is the trick number 1? What you have to remember? So now I will reveal the trick number 1. So what is the trick number 1 in case of concentrations? So in case of concentrations, okay, so what is the trick box? See here. So increase in the concentration of the reactant, then equilibrium shift in the direction to decrease the concentration of the reactant. So where it is decreasing equilibrium, in reactant concentration, in which direction decreases? A reactant concentration decreases in the forward direction. So that's why it favors the forward direction. Are you clear? It is the forward direction. Okay, that you have to remember. And next, product B concentration increases. Whenever product B concentration increases, equilibrium shift in the direction to decrease the concentration of the product B. So here decreasing. Product B concentration when decreases, students? In the backward direction. So that's why equilibrium shift in the backward direction to give the good product and it minimize this effect. That means to minimize the effect of increase in the product B concentration. So that's why it is which direction? Backward direction is favorable. Backward direction. This is the trick number 1. You have to remember this trick number 1. Clear? This is the trick number 1. Right. Now, next case, concentration completed. Next one, temperature effect. So what is the temperature effect? Second factor. So what is the temperature effect? In case of temperature, students, in case of temperatures, we have two types of reactions. Here one is exothermic reaction, another one is endothermic reactions. Exothermic and another one is endothermic reaction. Okay, endothermic reaction. Exothermic reaction means what? See here, exothermic means heat is released. Exo means releases, therm means heat. That means the reactions which releases heat outside, those are exothermic reactions. The reactions releases heat. Clear? The reactions which releases heat. Clear? Releases heat, those are exothermic. The reactions which absorbs heat, those are endothermic reaction. Endo means absorb, thermo means heat, absorbs heat. Are you clear? The reactions which releases heat, the reactions which releases heat, the reactions which absorbs heat, endothermic reactions. Clear, students? Now, how to identify exothermic and endothermic reactions? See here, equations I am taking just one example. A plus B gives rise to C plus D. Here delta H is equals to negative given. So negative. Delta H is equals to negative. Delta H is equals to negative given. That means delta H negative indicates what, students? Delta H negative means it indicates exothermic reaction. Exothermic. It is an exothermic reaction. Now I am taking another example. See here. A plus B gives rise to C plus D. Here delta H value given positive. Are you clear? If delta H value given positive value. So delta H positive means what it indicates, students? It is an endothermic reaction. Means heat is absorbed here. Endothermic reaction. Here more heat is required. More energy is required. Here less energy required. See here. Exothermic reaction means already heat is releasing here. Understanding? So that means in this reaction heat is released. Negative indicates exothermic reaction. Amount of heat is released. So that's why you should not give the temperature or you should not increase the temperature here. That means less temperatures are favorable here. In case of exothermic reaction, already the reaction is releasing heat. Exothermic releasing heat. That's why you should not give the you should not increase the temperature. You should not give the temperature. Are you following? That means less temperatures are favorable here. Are you clear? Less temperatures favorable. Okay, less temperatures favorable. Now coming to here, endothermic reaction. Here heat is required. So that means here high temperatures are favorable. So that means when we are giving the high energy, high temperatures are favorable. So that means here when we are giving the temperature, the reactants absorb heat energy and they convert into the product C plus D. So that's why it is an endothermic reaction. So that means here high temperatures are favorable. Clear? Less temperatures favorable. If suppose we are giving the in case of exothermic reactions, if you are increasing the temperature, so if you are increasing the temperature, what will happen, students? We won't get the good amount of the product, good yield of the product. So that means backward reaction takes place. That means here C and D products convert into the A, B reactants. Are you following? So these reactants convert into the products, students. So that means we won't get the product good amount of the product. So that means temperature increases in the case of exothermic reaction, then backward reaction takes place. Understanding? So here backward reaction takes place. Clear, students? So that's why here which temperatures are favorable? Low temperatures are favorable in case of exothermic. In case of endothermic, high temperatures are favorable. Clear, students? Okay, so now here see trick box. Trick number 2 based on the temperature effect. Trick number 2. Trick number 2, in case of temperature effect. Okay, in case of temperature. Now what is the trick number 2? In case of exothermic reactions, you have to remember these tricks, students. Exothermic reactions. In case of exothermic reactions, students, exothermic reactions, less temperatures are favorable. That you have to remember. Less temperatures favorable. Okay, next, in case of endothermic reactions, in case of endothermic reactions, which temperatures are favorable? High temperatures are favorable. Clear? High temperatures favorable. So these are the two conditions. Okay, this is the trick number 2 you have to remember, students. Clear? Very, very important trick number 2. Clear? In case of exothermic reactions, less temperatures favorable. Endothermic reactions, high temperatures favorable. How to identify exothermic, endothermic? Any reaction releases heat, delta H is negative, they will give, or delta H is equal to positive. Negative means exothermic. Exothermic means less temperatures favorable. Delta H value positive means it is endothermic reaction, high temperatures are favorable. Clear? This is the trick number 2. But in case of some reaction, students, they will mention along with the reaction, they will mention the plus Q or minus Q, students. Understanding? So there, how to identify exo or endothermic reaction? See here, in different cases, students, some reactions they will mention like this. See here, reactions A plus B gives rise to C plus D plus Q. Okay, this is plus Q kilojoule. Like this they will mention. So that means in the reaction itself they will mention here amount of heat. So plus Q kilojoule along with the product given. So that means here amount of heat is released. That means plus Q kilojoule is there, means you have to identify, you have to understand this is the exothermic reaction. Which reaction? Exothermic reaction, students. If delta H is equal to negative given means you can easily identify that is exothermic. If along with the reaction they given plus Q kilojoule, that means you have to identify it is an exothermic reaction. Exothermic reactions, which are favorable, students? Exothermic reactions, less temperatures are favorable. Clear? Less temperatures. Now in another case, students, A plus B gives rise to C plus D minus Q kilojoule. Okay, see here. So minus Q is there, minus Q kilojoule is there. That means it is not an madam told delta H is equal to negative is there, means exothermic, not negative. It is not an exothermic reaction. It is along with the product given. So that means the reaction will become here A plus B plus Q gives rise to C plus D. This minus Q I am taking left hand side, then it will convert into plus Q. That means the reactants absorb heat and convert into the CD products. So that means it is an which reaction, students? Endothermic reaction. So here you have to identify minus Q kilojoule is there, endothermic reaction. Endothermic reactions means which temperatures favorable? High temperatures are favorable. Clear? High temperatures are favorable. Right. Now this is the trick number 2 you have to remember. Clear? So exothermic reactions, less temperatures favorable. Endothermic reactions, high temperatures favorable. Clear, students? Now so next one, third one. Temperature effect completed. Now pressure effect. Third one, pressure effect. See here, what is the pressure effect? So in case of pressure effect, students, pressure effect. Now see here, I am taking the one vessel. This is the gaseous mixture. Here one piston taking. Okay, now one piston taking. This is the piston. Clear? So what is this? Piston. So when we are increasing the pressure on this piston, so before how much their volume, gaseous mixture, this much volume is there occupied. Now whenever increasing the pressure on the piston, what will happen? Volume decreases. That means that the gaseous molecules come closer to each other. Now see here, I am taking one more beaker. See here. Now whenever pressure increases, what will happen, students? The same beaker, not one more beaker. Whenever pressure increases, the volume decreases. That means the volume gaseous mixture is like this. So that means volume is decreases, and here whenever pressure increases, the piston that means we are increasing the pressure on the piston, then volume decreases. Are you following? So pressure increases, what happened? Volume decreases. This is the Boyle's law. So that means what we can say, students? So pressure is inversely proportional to the volume. This is Boyle's law. Clear? Boyle's law. Pressure inversely proportional to volume. And one more law is pressure is directly proportional to the number of moles. So it is directly proportional to the number of moles. So whenever pressure increases, so what happens, students? Pressure increases. So remember, students, number of moles less, pressure less. Number of moles of the gaseous molecules increases, then the pressure also increases. Understand? The excess more pressure. Okay. So P is directly proportional to the N. Whenever pressure increases, we are increasing the pressure. Pressure increases. What happens, students? Pressure increases. Then the equilibrium shift in the direction to minimize this effect, to decrease the pressure. Understanding? So that means equilibrium shift in the direction to decrease the pressure. Are you clear? Shift in the direction to decrease the pressure. Okay, now direction to decrease the pressure. So pressure decreases means, that means the equilibrium shift in the which direction, students? Pressure less means number of moles also less. Correct? Pressure less, number of moles less. That means in which reaction number of moles less there, that direction equilibrium is shifting. So that means here one example you take, students. That means equilibrium shift in the direction, that means where the number of moles less, that side equilibrium shifting. So see here, one equation, N2 plus 3H2 gives rise to N2 plus 3H2 gives rise to 2 moles of ammonia reaction. See here. Now, whenever pressure increases, then what happened? Equilibrium shift in the direction to decrease the pressure. Pressure where less, and that means pressure decreases means number of moles less. So number of moles where less, students? Here 1 plus 3, 4 moles. Here for total how many moles? 4 moles. Okay. Here how many moles? 2 moles are there. So number of moles where less here? Left side or right side? Right side number of moles are less. Are you clear? 2 NH3 is there. Number of moles less. Number of moles less. That means equilibrium shift in the which direction, students? Forward direction. So 2 moles of ammonia is formed in the forward direction. So here less number of moles side, for equilibrium is shifting. That means which direction is favorable? Which reaction? Forward reaction is favorable. Forward reaction favorable. Clear? Favorable. Forward reaction is favorable. Clear, students? So pressure increases, equilibrium shift in the direction to decrease the pressure. That means here that means the equilibrium shift in the which direction, students? Where the number of moles less, that side equilibrium is shifting to minimize that effect. Are you clear? So what you have to remember here in the case of pressure effect, students? What you have to remember? Trick number 3. See here. Trick number 3. Trick number 3. In case of pressure, so that means pressure increases, what happens, students? Pressure increases, then equilibrium shift in the which direction, students? Shifts in the where number of moles less, that direction it is shifting. Pressure increases, equilibrium shift in the number of moles less. Are you clear? Pressure less. So pressure less means equilibrium shift in the which direction, students? Shift in the pressure less means the equilibrium shift in the direction to increase the pressure. Pressure is more means when it is more, number of moles more means pressure will be more. So that's why number of moles will be more. Shift in the direction where is the number of moles more, that side equilibrium is shifting. Clear? This is trick number 3 that you have to practice. Trick number 3. Next, fourth one, students. Fourth effect, catalyst. What is the catalyst effect? Fourth effect. Okay, see here. So generally catalyst increases the rate of the reaction, correct? Catalyst generally it increases the rate of reaction. So in the reversible reactions it increases rate of forward reaction as well as backward reaction, understanding? So here rate of forward reaction and rate of backward reaction, both reactions are increases, understanding? So catalyst increases the rate of forward and rate of backward reactions, both reactions it increases. That means equilibrium constant is equals to rate constant of the forward by rate constant of the backward reaction. That means both reactions it increases. Here K is equal to equilibrium constant Kf by Kb. That means here rate constant of forward and rate constant of backward reaction both increased by equal times. For example, I am taking here T time, here T. That means forward reaction T times increased means backward reaction also increased by how many times? T times only. For example, forward reaction is increased by 2 times. What about backward reaction? How much it is increased means what is the rate of backward reaction means it is increased by increased by 2 times. Are you following? Suppose see here any equation when catalyst is used in the chemical reaction, in the reversible reaction, the rate of forward reaction is increased by 2 times. What about the backward reaction? The option A, 1 time, 2 time, 3 time, 4 times. That means how many times it is increasing? Forward reaction how many times increase? The same number. Backward reaction also it is increased by same time. Are you following? Here T time, here T time. That means equal times, both increased by similar time. Are you following? Similar time, students. So that means here rate of forward and backward reactions both increased by equal times. Are you clear? So whenever catalyst is used, clear? Catalyst used, okay, catalyst used in the reaction. So what happens, students? Catalyst is used in the reaction, the rate of forward reaction and the backward reaction both increased by equal times. Okay na? So rate of forward and rate of backward increased by equal times. Clear? Equal times. Understanding? Increased by equal times. Both increased by equal times. That is the catalyst effect. That means catalyst is used means there is no change in the equilibrium constant. There is no change in the equilibrium constant. No change in the equilibrium constant. Next one, delta H value, change in enthalpy. That means here rate of both increased by equal times. That means there is no change in the composition of reactants and the products, and delta H value also constant. Change in enthalpy also constant. Delta H constant. And next one, the equilibrium mixture also constant. Understanding? So that means the composition of the reactants and the products remains constant. Equilibrium mixture also, these three constant, students. Understanding? So that means catalyst does not affect the equilibrium constant delta H equilibrium mixture, but what it is changing means equilibrium constant, it helps to achieve the equilibrium quickly, students. Okay now, catalyst trick number 4. What is the trick number 4? Catalyst helps to achieve the equilibrium quickly. This point you have to remember in case of trick number 4. Are you clear? So in case of catalyst effect. Okay. So last one is inert gas. Trick number 5, inert gas effect. Addition of inert gas at constant volume, no effect. Understanding? So in the equilibrium position, there is no change in the no change in the reaction, students, and that means no effect on the equilibrium state. Addition of inert gas at constant pressure, increase in the volume. This is the trick number 5. Okay, now so total 5 tricks I discussed with students. So these 5 tricks you have to practice, then very easily you can answer any MCQs of Lechatelier principle, students. Okay. Important MCQs of Lechatelier principle. First one, in the following reversible reaction, 2SO2 plus O2 gives rise to 2SO3 plus Q kilocalories. Q calories. Most suitable conditions for the formation of SO3 is asking question. Here 4 options given, students. So which is the more favorable to get the good yield of SO3? Question. So here plus Q calories is there. That means in the question itself, in the reaction itself, they given plus Q, and that means what it indicates, students? It is an exothermic reaction. Understanding? So it is an exothermic reaction. According to the trick number 2, it is an exothermic. Exothermic reactions, which temperatures are favorable? Less temperatures are favorable. Correct? Less temperatures are favorable. Yes, according to the trick number 2, I told you here, in case of exothermic reactions, less temperatures favorable. Yes, the given condition, given equation is exothermic reactions, that means less temperatures favorable. Okay, next pressure given here, another option. So less temperature is favorable. Pressure is, how much pressure is applicable? See here, in the formation of good yield of SO3 is asking. So whenever increase in the pressure, see here, now here SO3 number of moles, how much there, students? That means SO3 number of moles 2 are there. Here number of moles, how many are there? 2 plus 1, 3 moles are there. Are you clear? So here see here, so here Q calories means that it is nothing but exothermic reaction, less temperatures are favorable. And coming to here, whenever increase in the pressure, high pressures, the equilibrium shift in the decrease in the pressure. Here suppose high pressures are applying. High pressures applied means what we can say, students? The equilibrium shift to decrease the pressure. So decrease the pressure means equilibrium shift in the direction where the number of moles less, that side equilibrium is shifting. So that means here number of moles less 2 moles, here 2 plus 1 3 moles. That means equilibrium shift in the direction this side. 2 moles of S4, less number of mole side. That means here high pressures are favorable. Are you following? Less number of moles, less pressure, less pressure. That means which condition is favorable? High pressures are favorable. Are you clear? High pressures are favorable. Option C is the correct answer. Are you clear? Equation option C. Next, second question, in the manufacture of ammonia by Haber's process, the condition which would give maximum yield of ammonia is asking. So here plus Q kilocalories given. It is which reaction? Exothermic reaction. Exothermic reactions means which temperatures are favorable? Less temperatures are favorable. And here number of moles less given. Number of moles less means less temperature, less pressures. That means high pressures are favorable. Are you following? High pressures are favorable. Clear? So which is the answer, students? Low temperatures, high pressures are favorable. Low temperatures, so high pressures are favorable. Option A is the correct answer. Are you clear? Next question, see, which of the following, which change will shift in the direction towards the product I2 gives rise to 2I delta H 150 given. Plus 150 given, it is an endothermic reaction. It is an endothermic reaction. Endothermic. So it is an endothermic reaction. That means more temperatures are favorable. Clear? It is an endothermic. More temperatures are favorable. Clear? According to the trick number 2, more temperatures is favorable. That means option third one is the correct answer. Increase in the temperature. Are you following? If you are coming to the concentrations, iodine concentration I. So increase in the concentration of I. What is happening, students? Equilibrium shift in the decrease in the concentration of I. So equilibrium decrease in the concentration of iodine. Concentration of I. In which direction the iodine concentration decreases, students? Backward direction. But here we have to get the good product of iodine I. So that's why backward reaction is favorable here. So option 1 is wrong. Second option, decrease in the concentration of I2. So by decreasing the concentration, we are decreasing the concentration of iodine I2. That means equilibrium shifting the increase the concentration of iodine I2. So in which reaction concentration of I2 increases, students? I2 increases in the backward reaction. That means it is also wrong option. And fourth reaction, increase in the pressure given. Pressure increases given. Here less number of moles. Here 1, no, here 2 formed. 2 iodine. Now more number of moles. More number of moles means more pressure. Means less pressures are favorable. But here high pressures given. So it is wrong option. So option third one is the correct answer. So third option is the correct answer. Are you clear, students? I hope you like this video. If you like this video, please like, share, comment and subscribe my channel, students. Thank you, students. Thank you very much, students. Please subscribe.